So I thought I'd walk you through a full example, a full problem that 10.3 is asking, section 10.3 is asking you to do. What I've done is I've pulled question number 3 out of each of the 3 sections in chapter 10, and it deals with collecting the fertility rate of women in different countries and life expectancy. And they ask us in 10.1.3 to create a scatter plot of the data. And I think what we want to do is they're trying to make a prediction of, does the fertility rate of women in a certain country have any kind of predictive effect? Can we predict life expectancy from that? Whoops, I just messed that up. Okay, so the first thing you always want to do when you're looking at this kind of relationship, to quantitative variables, and trying to see if there's some kind of predictive thing going on. Notice I'm not saying cause and effect, but we're trying to see if we can predict life expectancy from the fertility rate. So the first thing we'll do is make a scatter plot. So I've highlighted the data for this exercise, and I'm going to insert. I showed you this in last week's video, and I'm sure you know how to do it anyways. I'm going to make sure I select a scatter plot, and I'm even going to go further than that and customize it a little bit, and have it draw in a regression equation, a linear, and I'm going to have it show me use the equation for the label. Okay, and I'll even have it show r squared. So we're going to do some of that calculation. So here's the scatter plot for this data. I'm seeing a negative association between fertility rate and life expectancy. Notice I didn't use the word correlation. It's moderately strong. It's fairly linear, I think. Got some points here that's kind of influencing the whole mix. But here's my regression equation, which predicts life expectancy is X, fertility rate is Y, and I know that because my fertility rate's on the x-axis. Okay, and it tells me that r squared is 0.867, so that tells me that about 87% of the change in life expectancy is explained by change in the fertility rate. So that's a fairly strong relationship that really lends that this might be a fairly good model. Let's see, what's my next? I did set up this video. Let's see, this spreadsheet, this slide. Let's see what happens. Yeah, so moderately strong. They want us to find a regression equation, which we did with the scatter plot. Now we want to make a prediction. So use your regression equation to find the life expectancy of a country that has a fertility rate of 2.7 and another one for another country of 8.1. So let me go back to my spreadsheet. Let's slide this off to one side, and you can certainly do this with your calculator, but since I've got this right here and I'm having memory issues, let's see, 2.7 and 8.1. 2.7, 8.1. So then what I'm going to do is I'm going to just have the spreadsheet calculate it. Equals, the slope is negative 4.706. I'm going to multiply that by 2.7, and then I'm going to add 84.873. And then since I did my work setting up the formula, I'm just going to fill that down and it'll automatically calculate it for me. So it says, now let's see if we're looking at this right. Let me get a pointer going here. So at 2.7, which is about here, it says the regression equation says I'd have a life expectancy of about 72 years. Well, this is right in that mix. I don't see anything too strange about that. I would agree. There's some variation here, and we'll explore that in a minute. But I'm not seeing anything too outlandish. Then it says for 8.1, so if a fertility rate of 8.1, that's telling me, oh, look at this. It's down off the graph. I was almost thinking, well, it'll be negative, but that's because my graph is stopping at 50 here. So what I'm going to take and tweak my graph a little bit. Advanced edit. And I'm going to come down to here we go. Not fertility rate, I want life expectancy. Yeah, let's see if we can't come up with a change in the min and max. Somewhere here we do this. Life expectancy. Maybe we go up here, the axes. Here we go. Left vertical. I'm going to make the min be 0. What is it? 0.59. I'm going to make it be 0.90. There. Didn't lose too much in the looks of it. So now if I say 8.1, well, I'm a little off my graph. That's down, way down here, 46-ish. And the question asks, which one of these you suspicious of? And what I'm hoping you've gathered from your reading and maybe watching those Against All Odd videos is that the 8.1 is suspicious because that 8.1 number is way outside of our collected data. So this is extrapolation, and we don't know what happens after your collected data. If you're close to the collected data, your regression equation is probably pretty accurate still. But when you start getting out this far away, you're going to start running the risk of this might not be following a linear trend anymore. So that's to answer this. The 8.1 is questionable because it is due to extrapolation is how we word that. Let's go back to my presentation and see what next. All right, so we did that. We're going to do a residual plot. Find the residuals and construct a residual plot. So I'm going to come back. I showed you how to do this in section 10.1. And so what I'm going to do is actually, since I've already got this formula built, I'm going to have to tweak it a little bit. So this is taking an input value and coming up with a predicted. So I'm going to label this predicted right here. This is just for me as a human being. And I'm going to copy and paste that formula right there. I could type it again, but I got to tweak it a little bit because it's not the next cell over, it's this one I want. Okay, so there's the predicted value, and I'll fill those down. And remember how it changes it automatically? Isn't that nice? It's the power of a spreadsheet. Then I'm going to do the residual. And remember, that's actual minus predicted. Maybe I'll move these over a little bit so don't lose them. So equals, so I'm going to do the actual life expectancy that came from the data. And I'm going to subtract the predicted from the line. And that's a positive 0.3 residual. And you can kind of see that. Let's see, what is it, 1.7? So it's one of these. It's probably that one there. I don't know. Maybe it's one of these. Other software will let you be able to click on the point. You can actually see it. This one didn't quite do it. So now what I'm going to do is I'm going to copy the fertility rate, select it, Control-C, and paste it. I'm going to select my residuals. And I'm going to Control-C it, but remember I got to do a paste special, or else the formulas will copy too. So edit, paste special, values only. And there's my residuals. And now I'm going to insert my residual plot. So I've selected fertility rate first, so they put that on the x-axis. And I'm going to insert chart, scatter plot. You won't do too much labeling. So what am I seeing? I am seeing no pattern at all right here. I'm seeing something going on that almost looks like kind of like a pattern. It just might be a feature because there's not too many points out that on that range. But I would say that this demonstrates enough random behavior. Maybe not here. Maybe not here. I'm not really thrilled about that, but we'll go with it. Enough for human behavior. Looking at R squared, that's a nice high value of explaining the change in life expectancy to the rate. Oh, we got to do the correlation, don't we? Or maybe that's next in the mix. So I'm seeing, I guess you should answer the question about residuals. I'm not seeing much of a pattern. I think a linear model is a good model to use for this data set. Let's go look at my slideshow. Let's see. Now I think I have you calculating the correlation. Yeah. Okay. So remember, we can just do this. We can say, I'm going to write the word correlation for me. Actually, I'm going to write the whole thing. I could just write R and do equals correl, start typing correlation, and then select your Y variables, comma, select your X variables. I think I got them all. It'll tell me if I don't anyways. So there's the correlation, a negative 0.93-ish. Fairly strong negative correlation. Remember what I said in the last video, if we take the square root of this, and then because the slope is negative, it will be that number there. So it's looking like a linear model is appropriate to use here. It's fairly strong association. In fact, there's the correlation, the linear correlation between the linear relationship between fertility rate and life expectancy is very strong, pretty close to -1. And now what do we got to do? So using the residual plot and coefficient determination, defend your thoughts. And so that's what I did about talking about how linear model's a good fit. Now we're going to do a significance test. Yes. So you know how we thought that this looked, or how I thought this looked, was a fairly significant, a fairly strong correlation. This significance test will give us a p-value and let us know that. So what I did is I created a spreadsheet here, inference for regression. I've got this linked in the class in the week 10 work, or week 11 work. I'm lost track. Week 10 work, and I'm gonna come back and select this data. And I'm going to paste it, Control-C. I'm going to paste that into this spot here. And you should be able to do this too. So what am I seeing? What have I done for you? Well, I already did the regression plot, or the residual plot here, so I'm glad that held up. It's calculating the correlation for me, calculate the percent variation. I've got another slope linear regression calculation. Now, what do we need to do? This is the regression interval. Let's see. I've got a test for this correlation. Let's see here. Get rid of this so I can see some more. There we go. At the 1% level, test for a negative correlation between these two variables. So if I come back here, if I want a negative correlation, that's a left tail test because the correlation is less than 0. I'm getting a p-value of 0. I'm getting a test statistic of -11. -11, almost -12, which is very, very extreme. So p-value 0. This tells us, yes, this is indeed a statistically significant correlation. Being as close to -1 as it was, I wasn't really questioning that. But now we've got a p-value, and we did a test to show that. What's next? So they want us to compute a 99% prediction interval for the life expectancy of a country that has a fertility rate of 2.7. So something I haven't talked about tonight in this video is this regression equation is only one regression equation of many. I mean, because we're going to assume we've got a whole bunch of other countries, or we could go take another sample maybe on another year even. I'm sorry. where we might get a different set of points and we might get a slightly different regression equation. So one thing that the calculating the confidence interval does for your prediction, that this is just a point estimate. These numbers here, the predicted values, are just a point estimate, like the X bars and the P hats were. So that's what these Y hat values are, just that one thing. So now we want to come up with a confidence interval to express the possible variation, because for any one point on this line, you could get a normal curve, a normal distribution of possible values. So what I did for you with this spreadsheet is all you have to do is change the level of confidence to whatever you want it to be, so as a decimal. And it'll already calculate the degrees of freedom for you. You can basically ignore all this stuff. Something's not working right with this equation. Oh, here we go. Number we want to predict from. We want to predict for a fertility rate of 2.7. So I'm going to change this to 2.7. I guess I should highlight that for you folks. There, that looks a lot better. And then these are all numbers that I use in the calculation that you would need if you were to do it by hand with a formula. So I'm 99% confident that the true, what am I trying to predict? The true mean life expectancy from a country with a fertility rate of 2.7 children per woman will be between 62.6 years to as high as 81.8 years. So I'm hoping you see how this is the same thing you've been doing, just a new tool. I'm not expecting you to do the formulas. In fact, I don't want you to do the formulas. I'd like you to try playing around with the spreadsheet. Do some problems out of the book. You can use the spreadsheet to do any MyOpen Math questions that I have for you this week. Okay. So I hope this video has probably got, let me make sure I've done everything on my slideshow. Yes, I did. Okay, so I'm hoping this is enough. I can certainly do some more for you if you want. You could try recording a video or do some more, or just show your work in the forum. Okay, so I'm going to stop and keep this rolling.